Okay, in general, there are two approaches to anomaly detecting anomalies. So anomaly detection approaches. There is one supervised, there is one unsupervised. Let's start by the unsupervised. There are many algorithms to detect the anomalies in an unsupervised way, and why there are many? Because none of them are totally satisfactory. There's no panacea here. There's no solution for all situations. And this is why scientists and algorithm designers, they come with new ideas. We learn only one of them, the simplest one, which is called distance-based anomaly detection. Okay? It is about finding anomalies based on distance. If you recall, I showed you one example of this case, that we had a colony of cases, or maybe two of them, and one very different. The distance-based algorithms is working like this. It calculates the average distance of every point to every other point. Okay? And then for let's say for this one, let me zoom in. And let's say for this one, the distances are like this. Okay? The length of, so this is a Euclidean distance, right? The length of these lines. These are the distances. And one here. What about the one that I color it in purple? Well, the distances of that one would be like this. And you can see that if you average all distances, this one would have a way higher distance, average distance to other points. So there are many algorithms that they work based on the idea of average distance. Some of them do not calculate the average distance to every other point because it's very computationally expensive, but they calculate it, for instance, to the centroids, to the clusters, and so on and so forth. Okay? But the idea is the same. The idea is if one point, distance-wise, which is this similarity, so distance is this similarity. So if one point is distance-wise on average higher or farther from the others, then that might be a candidate for an anomaly. But what would happen if we have a point, let's say, okay, I need a new point. What would happen if we have a point here? Is this an anomaly again? Well, that's the point, that being anomalous or anomalousness is a degree rather than a sharp 0 and 1. So we can say that this one is the most anomalous case. This is the second most anomalous case. Okay? Even we can define a range, let's say something between 0 to 1, and then saying that this is 1, this is probably 0.8. We can call it anomaly index. We can define it something like this, okay? It is 0. And for instance, for this one, it is 0.5, for this one is 0.3, and so on and so forth. In that case, we can define a threshold. Anything above or equal to 0.8 would be considered as anomaly. And then the anomaly would be something 0 and 1. But before that, we have a continuous variable called anomaly index. So the summary is anomalousness is a degree rather than a sharp 0 and 1. We can set a threshold for it and convert it to a 0 and 1. But anyway, anomalous being an anomaly, it's more like a spectrum rather than a categorical variable by nature. And the only unsupervised approach of anomaly detection that I want you to learn is distance-based anomaly detection, which is based on calculating the average distance of a case from the rest of the cases. If this average distance is very far, is very high, then we can be quite certain that there is something suspicious here. Like we have an anomaly here. But what about the supervised approach?